How are polynomials graphed on a coordinate plane? Breaking news for students and educators alike. The question on many minds today is, how are polynomials actually graphed on a coordinate plane? With the school year in full swing, understanding this topic is more relevant than ever. Many learners are seeking clarity on how to visualize these mathematical expressions. Let's break it down in a straightforward way. To graph a polynomial, the first step is to find the roots, also known as x-intercepts. This means solving the polynomial equation when it is set equal to 0. These roots indicate where the graph crosses the x-axis. If you have a polynomial in factored form, the roots are simply the values that make each factor 0. Next, you will want to determine the y-intercept. This is done by evaluating the polynomial at equal to 0. The result will show you where the graph crosses the y-axis. Now let's talk about end behavior. This refers to how the graph behaves as x approaches positive or negative infinity. The leading term of the polynomial, which is the term with the highest power of x, plays a key role here. If the leading coefficient is positive and the degree of the polynomial is even, the graph will rise on both ends. If the degree is odd, one end will rise while the other falls. If the leading coefficient is negative, the directions will reverse. Finding turning points is another important step. A polynomial of degree n can have up to n-1 turning points. These points can be local maxima or minima. You can estimate these by calculating the derivative and finding where it equals 0, or by plotting additional points. Once you have this information, it is time to plot points. Choose several x values, calculate the corresponding y values, and plot these points. This will help shape the curve of the polynomial. Finally, connect the points smoothly. Make sure the graph passes through the roots and reflects the end behavior and turning points you have identified. When polynomials are presented in factored form, graphing can be simpler since the roots are immediately visible. Using synthetic division or polynomial division can help find factors or simplify the polynomial for easier graphing. In summary, graphing polynomials involves a combination of algebraic techniques and an understanding of how the polynomial's degree and leading coefficient affect its shape on the coordinate plane. This approach makes it easier for learners to visualize and grasp the behavior of polynomial functions step by step.